move on and I will stop sharing because I'm going to pass the floor to my colleague Rita, because now we are going to walk you through the Panacea Toolkit as an integrated solution for cybersecurity in healthcare. This was through a series of videos, of various duration. So we're going to start with the dynamic risk management platform. So Rita, I think we're ready for the first video. We've been talking a lot this morning about the role of risk management. This is our proposed solution to deal with all of the threats in a very dynamic landscape. There we go, it's coming. Thank you very much, everybody.
Good morning, I am Silvia Bonomi. I am an assistant professor at Sapienza University of Rome, and together with my colleague Simone Lenti, we are going to introduce you to the Panacea Dynamic Risk Management Platform. The platform has been thought with a clear objective in mind, and the objective is supporting a cybersecurity operator in handling the cyber risk management process. This is because cyber risk management is a complex and time-consuming task, especially in large-scale organizations like healthcare and hospital institutions, as those we are targeting in the project. The main sources of complexity are given by having a large attack surface due to hundreds of devices that are composing the IT infrastructure, including also medical devices, and the thousands of vulnerabilities that are affecting those devices. Another relevant source of complexity is due to the fact that in the healthcare domain there is a huge interaction between human beings and devices, and most of the time human beings are not technical staff that is well trained about security, but humans are typically represented by medical staff. And last but not least, there is also a problem related to the identification of the critical assets of the system that is clear to technical people, but it's less clear to the analyst that needs to analyze the risk. The tool is offering a platform to assist security operators in the computation and the assessment of the risk. And in particular, if we consider the classical 5-step approach for assessing and evaluating the risk, DRMP will assist the security operator in the step 2, risk identification, by providing visual information about vulnerabilities affecting the system and how they can be aggregated to compose multidimensional attack paths. It will support the security operator during step 3 and 4, risk analysis and risk evaluation, by implementing an automatic logic for quantitative risk estimation. And finally, it will assist the security operator in step 5, that is the risk treatment, by suggesting both technical and non-technical mitigation actions that can be deployed into the monitored system in order to reduce the level of the risk. The system has been implemented and tested into an emulation environment. And basically, we are currently running experiments in an extended scenario. The first emulation environment is the one that you can see on the left of the screen, that currently represent one of the laboratory made available by Fondazione Policlinico Gemelli, while the one represented on the right is an extended version of the scenario that is still including the original one, but emulates the fact that this laboratory is then connected to other structure and can be also attacked from the outside. I leave the floor to my colleague Simone, that we will drive to a demonstration of the system.
Good afternoon, I'm Simone Lenti, and I'll show you a quick tour of the visual analytics environment of the DRMP platform. The security operator logins in the visual analytics environment, and in the home page, he can view summary information about the distribution of vulnerabilities in all the snapshots computed by the platform. He can select one of these snapshots. Here we selected the last one. And now the home page is updated with the results of the default risk analysis computed for that snapshot that we briefly present later. Using the different views of the environment, different analyses can be performed. In the attack graph view, all the possible vulnerability exploits between the entities are represented. The size of the nodes is proportional to the number of exploits involving them, the red portion to the exploits targeted to the entity, and the green one proportional to the exploits outgoing from it. Inspecting a node, it is possible to analyze the vulnerabilities that affect it. In the bottom of the view, summary information about all the vulnerabilities are presented. The encoding of the graph can be updated to make tailored analysis on specific nodes of the network. In this example, we select again our medical device, and we now can analyze all the exploits that involve them. The risk analysis view allows to perform custom risk analysis. The first step is the selection of the targets of the analysis in the dependency graph. For example, here we select the report lookup business function, and we decide also to add another business function, for example, test validation. We can customize the impact, or we can move to the selection of the sources. Here we have to select all the possible sources of the attack. For example, we notice that there are a lot of possible exploits outgoing from an internal attacker. And we decide also to add one of these workstations as a possible source of attack. We can specify the roles, or we can modify the probability that the node is a source. And then we can provide a name to our query, and we can execute it. The security operator can even load previous computed queries. For example, he can inspect the default query computed by the platform for this snapshot, and he can see all the impacts on all the business entities selected by this query. For example, here urgent analysis and test execution have the higher risk levels, but cannot be impacted by naive attackers, while the others have lower risk levels, but can be impacted even by a naive attacker. On the attack graph, all the computed paths are visible, highlighting in red the targets of the attack. Here, these two medical devices, and in green, the sources of the attacks are highlighted. On the bottom, the mitigation action proposed by the system to face this analysis are presented and projected to the graph.
To conclude on the dynamic risk management platform, it is important to say that the software is in validation status now. We are refining the last details for the Panacea project and validating in a complex environment like the one that you can see here in this slide. The dynamic risk management platform is going to be re-engineered by RIA in order to add it as a product within its portfolio, and is going to be offered probably with licenses, so yearly license with maintenance, installation on premise, or installation on the cloud and connection directly to the network to be monitored, or it can be offered as an assessment service. So when a Tantum is installed, is deployed, perform one or two iterations of risk analysis, including the suggestion on the treatment side and the mitigation actions, and then is undeployed. Those are the two models that we are envisioning right now.
Thank you. That was our dynamic risk management platform and the proposed service delivery model. We'll now move on to our tool for secure information sharing. So thank you, Rita. Here it comes.
Welcome to the presentation of the Secure Information Sharing Platform, or CISP. CISP addresses an important problem for healthcare organization: transfer of information between the same organization in different premises, between multiple organizations, and on the same nation or cross-border. Information should be transferred in a secure way and, of course, in a timing fashion. That usually doesn't happen. Healthcare organization transfer data by using non-secure means and non-GDPR compliant means, fax, email, messaging, or even by exchanging physical media. CISP enabled this secure information sharing of any type of data from medical images to discharge reports, etc., within the same organization or within multiple organizations, the same nation or cross-border, fully GDPR compliant, throughout a secure exchange channel, including strong end-to-end encryption, encryption of databases, and so forth. It's based on a previous agreement, of course, between the different healthcare organizations. CISP allows a very fine-grained and customizable data model and the data access control, so it's possible to customize the type of data that are transferred and also to anonymize part of the data that may need to be anonymized. And of course, data visibility via hierarchical groups is extremely important and is very well addressed. The data model is customizable, so it's possible also to change the type of data and the facet that those data are using in order to be transferred. And there is a full interface, including warnings, notifications, which enables a much more user-friendly type of interaction. The deployment model is hybrid. It can be fully centralized or fully peer-to-peer, or an hybrid version of the two with clusters of federations, for example. It's also integrated with identity management platform developed within Panacea, and uses for authentication can use a single sign-on in order to be integrated in a seamless way within the information system of an healthcare organization. On the next, a demo of the Secure Information Sharing Platform.
Welcome to this CISP demonstration. I'm going to start the demo by logging in as a doctor from FTP. This takes me to the dashboard view. On the left, we can see the different functions that we have available with the different dashboards. Dashboards can be organized to show the information that I need. To demonstrate the main capability of CISP, we are going to imagine that the dialysis patient needs to travel to Greece from Italy. During his vacation, he needs to have medical attention. Therefore, we need to transmit his parameters to the facility in Greece. CISP allows to extend and configure what kind of information we record in different templates. I'm going to create a new record based on the dialysis template. As you can see, the form changes, and I'm now entering the information needed for the template. On the right side of the application, you can see a participant list. This allows us to configure the visibility for this record. I can assign a handler, but I can also assign a group. So in this case, I'm going to assign the group of doctors to have access to this record. Each record is always in a specific state once it's created. We can see the workflow here. It is specific to this template type and can be configured in order to align with what the business needs. You can also restrict the different transitions to a set of rules. I just change the state to be in triage. If we have more information inside the system that we want to reference, we can create references. For instance, if we have a patient summary or something. Here I'm searching for the data I have about John and linking this up to this information. If we have any attachments, we can also assign this to the record, for instance, medical images or other files that we are keeping about the patient. Finally, we have the comment section, which allows us to write different notes about the patient. And on the right side of that, you can also see the history window, which serves as an audit record for what has been modified on this, at what point in time and by who, and what was changed. In order to share this information with an external organization, I will enable the sharing. Fields in blue are shared. You can see that a certain part of this record is already shared. But then we can also configure on an attribute level what attributes we also want to share. This allows us to not send the entire set of information we have. Maybe we have some internal fields, so we are keeping some data that we do not want to share with the other healthcare organization. On the right, in the participant list, we can also now see that we have a constituents and a shared with field. Healthcare organizations are ordered into different constituents, which is a grouping of different healthcare organizations with some kind of pre-agreement about sharing data between each other. Here I'm selecting the FPG, 7 Healthcare Region of Crete. And then I also need to assign which organization inside this constituents I'm sharing with. So now I'm going to share this with the General Hospital directly. Then we have a warning, which is configurable as well, which will allow us to ensure that patient consent has been signed. Finally, we can also write notes between different healthcare organizations. So here I'm just going to inform about an upcoming vacation of John and send that as information to the General Hospital directly. Now I'm going to switch over to the other server where General Hospital Curriculum is installed and signed in as a doctor from their side. Now we can see that I have 2 new notifications. So one ticket was created and then later updated. And this is only the information that was shared with us. But before we can work on this information, we need to assign the participants inside our organization. So I'm going to choose the doctors for visibility on this one as well. In order to support cross-border requests, we have a feature which allows us to map a record into another template type. We call this the clone feature. And the clone feature basically allows us to take an internal template and map it to some kind of common understanding. So in this case, it doesn't make sense, but you can see that I'm taking the dialysis assistance request and turning it into a magnetic resonance image. You can see the different fields that we have available and what kind of mapping I want to do of these fields. And then we can share the clone ticket as normal. Thank you for watching the demonstration of the CISP.
So the Secure Information Sharing Platform is part of our current portfolio of security products in RIA, and is in advanced validation status. It's going to be offered with licenses, so the organization can install one more or more different instances of the application and then directly access to it from multiple premises, for example. Or it can be now offered as a service, so it's hosted in a public or private cloud, and then it's accessed in a multi-tenant way by different organizations. So it's completely customizable. Thanks a lot.
So that was our tool for sharing information securely. We'll now move on to our identity management platform. So here it comes.
Welcome to the Identity Management Platform presentation. We are going to present now the human-to-machine authentication, which is actually about access control. So you all know what access control is. Here we are talking about logical access control, which means to all the systems that are linked to the IT system of the hospital. So you are using it a number of times per day, and they are everywhere. So at the point of care terminal, for instance, but also on your workstation, on the radiology equipment, or whatever. So today, probably the solution you use is very likely to be based on login and password and relying on Windows. Now, what is the current situation? The current situation is that credentials are written on post-it, and very often the credentials are used for a machine and not for a person. They are not corresponding to any actual users. They are linked to the boss of the department, for instance, or maybe the assistant. And it's not very convenient, so on some terminals, authentication is even disabled. So why this situation? You know that good password management requires that passwords are long, are containing special characters, and are changed very often. Therefore, it cannot be 1, 2, 3, 4. They are difficult to remember. Also, in healthcare, people have very important things to do, and they are not so much concerned with security. They prefer to have other activities. And typing passwords, when they contain special character and you need to look at the letter one by one, is time-consuming. What we have learned with that is that if we put something for security in place, it's not going to be used unless it's very easy to use. Otherwise, workarounds are going to be found. So now let's have a look at the video. Thanks a lot for your attention. If you have questions, please do not hesitate. We are here to listen.
That was our identity management. We're now turning our attention to our security by design framework with a short video explaining what it means, and then the example of two tools. One is security design support platform, and the other one is a compliance support design tool.
COVID-19 has pushed the healthcare sector towards an escalating digitalization and interconnection. Acquisition of new devices and software, such as remote monitoring devices, telemedicine platforms, and still better, telehealth applications, will represent a challenge for vulnerable hospital IT systems and for patient privacy and safety. Cybersecurity of these systems and their interaction with our legacy structures is more essential than ever. Security by design utilization, when we procure new systems and devices, is probably the most important building block for the future of patient care.
Due to lack of cyber awareness within the healthcare sector, our response is the Security by Design framework, in order to overcome the design limitation of medical devices and healthcare software solutions, which currently don't specifically or poorly include the security engineering aspects regarding the cyber risks. The main concept of Security by Design framework is to make systems free of vulnerabilities and impervious to attacks as possible through different cybersecurity measures that should be integrated into the design process, so that the devices will be designed secure from the foundations. Indeed, Security by Design approach follows different steps, such as the context definition, the relevant standard identification, the standards mapping, gap analysis and extraction, the conformity assessment, and the risk assessment.
In Panacea, the risk assessment is covered by a dedicated secure design support platform developed by RIA, while the conformity assessment, for which continuous evidence collection and audit performing are essential, is supported by the compliance support tool developed by RINA. These two technological solutions compose the Security by Design framework and will be explored in the next videos.
The compliance support tool is a powerful instrument to support the quality assurance process during the whole life cycle of a medical device or system. It enables the client to put in place an assessment audit of the process, supporting health devices or systems providers and quality responsible, ensuring compliance to current standards in the health sector. It also allows a flexible configuration and management of the standards that can be grouped in templates to fit the needs of the users. The compliance support tool provides the user with checklists fed from predefined ISO referenced templates. It allows to collect all the records needed to assess the compliance, such as documents, images, or notes from interviews, and to easily associate them as evidences to the checklists. An intuitive summary report page shows useful information with tables and charts to communicate results such as compliance coverage over system requirements or processes and tracing over different sessions or trend over time. At every phase of the auditing activity, a notepad integrated in the report page is conceived to collect comments and indications to easy information tracing and allow aware decisions to improve the results obtained from the conformity assessment. The target users that can benefit from this solution are medical device manufacturers, healthcare application providers, and hospitals. We foresee three different applicable service delivery models. The first one is the assessment service, in which the compliance support tool is used to perform a specific compliance assessment of a medical device or healthcare software application. The second one is the advisory service. Using the Security by Design framework methodology and the compliance support tool, RINA can provide advice to a medical device manufacturer or software application provider during the development and the design of their product, and also can provide advice to the hospitals during the deployment of a new medical device or software application. Finally, the capability setup service plus licensing compliance support support tool. In this case, RINA provides an advisory service for the implementation of the Security by Design framework methodology and a compliance support tool license to the medical device manufacturer or hospitals, comprehensive of training, releases and content updates. And in this case, the stakeholder will be able to use autonomously the Security by Design framework and the compliance support tool.
Healthcare is embracing digitization. It's a revolution that presents immense opportunity, but also brings new risks. With thousands, even millions of moving parts and people needing to communicate and coordinate, healthcare is uniquely complex and dynamic. Arguably, no sector stands to benefit more from the seamless integration of technologies and sharing of data. But every element of a complex system, including medical devices, presents a potential hazard, a weak spot that cybercriminals will seek out and try to exploit. The complexity we seek to conquer with digitization could be its undoing. That's why security in healthcare information systems and medical devices is fundamental and needs to be designed in from the very beginning. European projects such as Panacea have given RARE the opportunity to apply our experience from the space sector into healthcare. With our Secure Design Support Platform, we provide a powerful new tool that lets users create more secure, complex systems while using Security by Design principles. It helps designers perform security risk assessments for complex systems during the different phases of the engineering lifecycle, automatically calculating the risk level of each asset based on the expert's choices. The platform also gives system architects a clear overview of the security envelope of the system, enabling a better tuning of security requirements and a proper management of the cyber risks. Underpinning this is a deep understanding of the challenges the healthcare sector faces. There are three main areas of vulnerability. The first is the product. Millions of devices in hospitals, laboratories, pharmaceutical companies, doctor surgeries. Then comes the process. How do these devices connect to each other? Last, but definitely not least, the people. Are they logging in and out correctly? And how strong are their passwords? The Secure Design Support Platform lets users click and drag to build the system or medical device they want. All the capability they need is there, but in the background, maximizing ease of use. The platform interacts with system and software requirements and design elements and easily assesses threats, vulnerabilities, and risks, categorizing them with color identifiers, red to green. System designers don't have to worry about every possible connection or weak side of the system they are building. This tool identifies them by highlighting major risks and providing the means to reduce them by introducing tailored security controls. The tool itself is well protected. Confidential information is guarded through role-based access, letting key players communicate securely, while also storing project information and assets so design histories can be traced and checked. The Secure Design Support Platform simplifies complexity. Building or joining complex systems together becomes a more manageable task, despite the many moving parts. Above all, it creates confidence that no job is too big and that the end results will always be secure. For more information, please contact info@raregroup.com. www.raregroup.com.
The Secure Design Support Tool is a part of the current RIA security product portfolio and is currently used in multiple activities for risk analysis and security by design for complex systems in healthcare, defense, and space sectors. We are currently offering it with a license, generally yearly license with maintenance and announcements included. And we are also offering it as part of general assessment advisory services, for example, for security by design and risk analysis. For any information, you can contact www.regroup.com.
And so that was our approach to security by design with two dedicated tools. We'll now look at resilience, governance, and financial viability. We've been talking a lot about budgets.
This presentation is about the security governance models and decision support tools developed in the scope of the Panacea project. In a general context, organizations are adopting cybersecurity governance models to manage cyber risks as effectively as possible. One of the main issues faced by the healthcare organizations is the lack of specific tools able to provide decision makers with concrete and actionable recommendations in order to evaluate the cybersecurity management system of the healthcare organization, create a specific IT security entity to govern the cybersecurity, and evaluate the cybersecurity return on investment. At this scope, two main tools have been designed, developed, and pre-tested in specific healthcare contexts. From one side, the Panacea Resilience Governance Model, able to cover the first two issues. It is composed by two independent but strongly related modules that are the Healthcare Cybersecurity Governance Tool and the Healthcare Cybersecurity Organization Structure Model. From the other side, the Panacea Financial Viability Multidimensional Model, able to solve the third mentioned issue, which is composed by ESMS measurement indexes and by a specific cybersecurity return on investment. So going more into detail of the first model and starting from the Healthcare Cybersecurity Governance Tool, what we can say is that the main purpose of the tool is to evaluate the overall information security management system of a healthcare organization. That is a standard system for the cybersecurity management. The HCG tool is based on the main European and national reference security standards that are highlighted in this slide. Thanks to this aspect, the tool can identify the level of gaps of the SMS with respect to the different cybersecurity standards tailored to security aspects of the healthcare domain. The HGC tool allows to identify the dedicated mitigated actions to be carried out in order to build or improve the ISMS, acting as a fundamental tool to support management decisions. The output of the tool has a graphic interface to better understand the results. Moving then to the Healthcare Cybersecurity Organization model, the main purpose of the model is to manage, deploy, and improve the cybersecurity governance system of the healthcare organizations. The model is made up a set of guidelines for designing a specific IT security organizational entity. This model allows to identify specific roles and responsibilities for governing cybersecurity. Moreover, the main concept of the IT security entity modeling is to map roles and responsibilities necessary to govern, manage, and implement cybersecurity across the organization. In particular, the application workflow consists in answering to following main questions for each ISMS security process related. Who, what, where, and how must, can, should this specific cybersecurity issue be managed? The outcome of this application workflow led us to design the IT security entity. Finally, focusing on the financial multidimensional viability model, what we can say is that the model expands the outcomes of the RGT tool by adding an economic dimension to the ISMS maturity assessment. In fact, its main purpose is to evaluate the return on investment in the main field of cybersecurity. First of all, it has been approached a map of the investment needed to reach the maximum maturity level of the organization's information security management system. Therefore, ESMS maturity level is directly linked to each security process and related systems through adimensional indexes, such as the ESMS maturity level growth and the ESMS economic effort. The definition of dimension indexes allowed us to outline the formulation of the cyber ROI related to a specific investment scenario, which has been defined as their ratio. In this way, decision makers can have the capability to assess the cybersecurity actions, even thanks to the economic financial dimension of the cyber ROI index associated to different possible action scenarios that the RGT tool helps to define. To conclude, the tool and the model, which have been designed, developed, and pre-tested, can help organizations in order to evaluate the cybersecurity governance system, realize an innovative IT security structure entity complying with the significant standards, but also with the particular reality, define the set of actions to put in place at the main aim of increasing the compliance needs of the organization, and prioritize cybersecurity investment through the definition of the cybersecurity ROI. Finally, with specific regards to the service delivery model, they can help and standardize a typical consulting service in the specific healthcare domain related to security governance issues. Thanks for the attention.
Right, so we'll now look at how Panacea is trying to tackle the big challenge of secure behaviour with our secure behaviour nudging tool.
Hello, my name is Professor Lynn Coventry from Northumbria University. Today I would like to introduce you to the Secure Behaviour Nudging Toolkit. The aim of the toolkit is to provide tools to identify ways in which staffs work around cybersecurity, the underlying reasons for the adoption of these workarounds, ways to change these behaviours if the workaround reduces cybersecurity, and ways to evaluate if that nudge has been successful. Firstly, it is important to acknowledge that employee behaviour can undermine any technical security controls. Attackers are well aware of this, and rather than spending hours trying to break through the technology defences, they are targeting users to let them in. You might ask yourself why there is a problem when the security policy tells employees how they are expected to behave. Unfortunately, just because staff know what they should do doesn't mean they will. I have mentioned nudging. Nudging is a way to encourage people to behave in a certain way through changes to the environment in which the behaviour is expected. Good nudges are timely, that is, they are delivered at a time when a person should be enacting that behaviour. Nudges may look simple, but they have been shown to be effective. For example, a pair of eyes watching you can lead to more honest behaviour. A red or green card can incentivise clear desk behaviour, and a proximity detector which flashes and vibrates can remind you to log out. So what is a Secure Behaviour Nudging Toolkit? It is a set of tools that help an organisation to identify and prioritise the insecure behaviours occurring in their workplace, identify how and why these behaviours occur, identify and design appropriate interventions, including nudges, and evaluate these interventions' effectiveness on an ongoing basis. Our toolkit contains 6 tools which help people to implement a process of continual behavioural improvement. The first tool is to identify the underlying attitude towards cybersecurity. This is a survey which covers different attitudes and also assesses access to different devices and data. The second tool outlines an approach to identify workarounds of current policies. This is a series of questions to form part of a discussion group. Firstly, looking at the behaviours in the workplace, and secondly, specifically asking about the importance and achievability of each behaviour listed in the security policy. Where achievability is low, then the workaround used for this behaviour can be explored within the workshop. From these tools, the behaviours can then be prioritised, and we can start to look at how each prioritised behaviour is being influenced. This tool, for instance, allows an organisation to list the behaviours expected from staff on yellow stickies as listed in their policies. These can be assessed for importance and also achievability. As the staff work together to rate how achievable they think a behaviour is, they can start to explain the barriers to that behaviour and how they work around it. The use of this tool can be complemented with workshops discussing the behaviours in the workplace and asking how a task is typically completed, and also with observations of behaviours in the workplace. The next stage is to prioritise the most risky behaviours and identify the most suitable intervention for each of these behaviours. Once a behaviour has been identified, then we can work with staff to understand more about how that behaviour has come about. Just say from this we prioritise sharing passwords with colleagues as a behaviour that is carried out and discuss when asked about the policy, do not share passwords. Now we can look at the influences of that behaviour. This can be carried out in a workshop by presenting participants with cards of influencers gathered from theories of behaviour and asking if they occur in the workplace. Here are some examples of the influencers of password sharing. You can see that there is a positive attitude towards this behaviour and people do not think they have the authority to change this in the workplace. Rather, they feel it is expected of them from senior staff and that it is a common behaviour. The next step is to look at how to influence the behaviour to change and how it can be nudged. Firstly, the team should work together to identify as many nudges as possible. Then the nudges should be evaluated to decide on the most feasible and potentially effective before developing and evaluating a prototype nudge. A tool we use for this is nicknamed Mindspace. This tool pulls together many different influencers from different theories. It provides another way to frame questions to explore the problem space. So, for example, if we were trying to improve the strength of passwords, there are a number of ways that could try to nudge that behaviour. So, for example, we could use a password strength meter, which shows how strong a password is as it is created or entered. Once the team have identified a list of potential nudges, we provide worksheets to help decide which nudge to develop. This includes guiding the user through evaluation of potential nudges based on some factors. These are the criteria we have currently included: technological feasibility, time and ease of implementation, disruption to work processes, whether or not a policy change is required, the financial cost of developing the nudge, the expected effectiveness of the nudge, how sustainable and generalizable the nudge is. Here are 3 nudges that we have designed using the toolkit and which were piloted across 3 health organisations. A poster campaign to raise awareness of the need to log out when leaving a workstation, badges to increase social awareness of who is conforming or not, and a bit of humour to increase the salience of the danger of using USBs without disabling them. The last step is to pilot, then roll out the nudge and evaluate if it is successful. Ideally, the behaviour would be measured directly, but this is not always possible, and we may need to rely on observation and self-reporting. It is important to run a pilot before full development of an intervention to ensure the nudge doesn't backfire. This does not need exact metrics, but involves a qualitative evaluation of whether or not the nudges would work and if people would find them acceptable. Take our badges example. In the workshop, people thought disincentives would be a good idea, but when we initially prototyped the badges and sent them out for review, there was some initial pushback and fear that people would not accept the negative framing. Lastly, it is important to treat nudge development as a cyclic process where the effectiveness needs to be continually assessed and new nudges developed as necessary.
That was our secure behaviour nudging toolkit, and we'll move on to now our last tool, which is on education and learning.
A secretary in the EU was found guilty and fined a large sum of money for inappropriately accessing the database and extracting confidential and personal data on a local celebrity who had recently undergone a medical procedure. This was then made public in the national media. Some data is deliberately misused, but it is often ignorance of the potential consequences that results in poor cybersecurity. The Panacea Secure Behaviour Education and Learning package has therefore been designed to highlight the sources of cybersecurity dangers and to address the direct link in healthcare organisations between secure cyber-related behaviours and practices and the health and well-being of patients, regardless of circumstances, processes or procedures. Designed and developed using a systematic approach by a team of highly qualified and experienced developers, the holistic training intervention is based on a thorough analysis of the current situation in the 3 partner HCOs acquired through workshops and surveys. It combines proven pedagogical methods and modern digital media to appeal to as broad a range of learners as possible. The learning aim is universal and is not limited to any particular target audience, use case, or scenario. Having spent the short time necessary to experience the tool, it is anticipated that all individuals working in, with, or for HCOs will acknowledge their role in adopting secure cybersecurity-related behaviours because of the very clear link between patient care, patient well-being, even after treatment has ended. The learning package stands totally independent of the organisation structure, governance arrangements, formal cybersecurity roles and responsibilities, processes and procedures. It highlights to all that cybersecurity is everyone's responsibility and that everyone is accountable for their behaviour. It promotes behavioural change by personalising the consequences of inappropriate cybersecurity behaviour to the learner, the learner's patients and the HCO itself. The learning package has been designed to be used as many times as required by the user. It has considered the diversity of the target audience and the broad range of potential users. Therefore, it contains minimal written or spoken words, relying on strong and recognizable imagery to depict the scenarios, focusing on 4 identified behaviors. They are use of insecure portable storage devices, insecure passwords and poor password management, insecure shared access to digital devices, and lack of attention when dealing with unusual communications. Delivery is via a video with a duration of less than 20 minutes. It is universal in format, MP4, and accessible from PC, laptop, tablet, or mobile phone. The end user simply needs to make the video accessible on their local area network, probably as part of their learning management system, and provide their staff, regardless of employment grade or employment status, with the time and equipment to watch it. The supplied evaluation plan guides the end user organizations through consideration of the whole range of factors involved in changing current behaviors, including learner capability, learner opportunity and motivation to change, particularly if there is interference from the presence of inappropriate policies, processes and procedures, historical or conflicting cultural practices, and the lack of recognition and reward for secure behavior.